So I'm going to do problem number 33, which is an unstable atomic nucleus of mass 17.10 to the negative 27th kilogram initially at rest disintegrates into 3 particles. One of the particles of mass 5 times 10 to the negative 27th kilogram moves in the y direction with a speed of 6 times 10 to the 6 meters per second. Another particle of mass 8.4 times 10 to the negative 27th kilogram moves in the x direction with a speed of 4 times 10 to the 6 meters per second. Find A, the velocity of the third particle, and B, the total kinetic energy increase in the process. So, you're given that initially velocity is 0 and mass is 17 times 10 to the negative 7 kilograms, so that's like my picture of just the thing at rest. And then I drew it after it disintegrates, so it gives you the M2, V2, M1, V1, and you're trying to find V3, and you can solve for M3 by just subtracting M1, M2 from the original mass. So and then you get the original momentum, because momentum is conserved, and then you get 0 because it was initially at rest. And then you plug in your momentum final, which has to equal your momentum initial. Your momentum final is going to be 8.4 times 10 to the negative 7 kilograms times 4.0 times 10 to the 6 meters per second I hat, because it's in the x direction, plus 5 times 10 to the negative 7 kilograms, or plus 5 times 10 to the negative 27th kilograms times 6 times 10 to the 6 meters per second in the j hat direction, because it's moving on the y-axis, and then plus 3.6 times 10 to the negative 7th kilograms times the velocity. And you got M3 by doing 17 minus 8.4 minus 5. And then you set that equal to 0, solved for the momentum in the x direction, momentum in the y direction that are given, and then I divided both of those by 3.6 times 10 to the negative 7th because they're like independent directions, and to get the velocity vector, which gave me negative 9.33 I hat minus 8.33 j hat megameters per second, because it's like 10 to the 6th. So you know that that's like a pretty like reasonable answer, because both your x and your y are moving in the positive direction, and your vector is like moving in the negative direction for both the x and the y sections. So then the second part is asking you to find the kinetic energy. So the kinetic energy initial is 0, just because it's 1/2 mv squared, the initial velocity is 0. So then I got the kinetic energy of the total system after by doing 1/2 times m1v1 squared plus m2v2 squared plus m3v3 squared. And I solved for v3 as like, instead of using the vector components, just using one number by using the Pythagorean theorem. So yeah, that's that. I got 1.25 times 10 to the 7th meters per second as that. Plugged in all the values and ended up with 4.387 times 10 to the negative 13th joules of energy.